Hello dear friends, welcome to my channel. Today's discussion is CSIR NET 2023. Suppose xt is the solution of the following initial value problem in R square. X dot is equal to x, x0 is equal to x0, and where a is equal to 5, 1, 4, 2, and which of the following statements is true? Which of this is the xt is bounded solution for some x0 is equal to 0, e to the power minus 60 mod of xt tends to 0 as t tends to infinity for all x0 equals to does not equals to 0, c and option d. So friends, this problem problem how can I solve? Because xt, okay, xt, right, xt is equal to x1 t x2t x2t and ax1 x2, okay, ax1 and x2 equals to x1 dash x2 dash. Okay, so 5, 4, 1, 2 and x1 x2 is equal to x1 dash x2 dash. So friends, x1 dash and x2 dash, so what we get? We get that x1 dash is equal to 5x1 plus 4x2 and x2 dash to x1 plus, so friends, now we just double derivative this portion, okay, so x1 5x1 dash plus 4x2 dash is x1 x2 double dash is equal to x1 dash plus 2x2 dash. Okay, so x1 double dash equals to 5x1 dash and x2 dash. X2 dash means in here x1 x2, okay, x2 dash. Okay, at first I check this portion, okay, just solve this problem, okay, my target is solving this problem. So x1 double dash and x1 plus 2x2, okay, just putting the value that x1 double dash is equal to 5x1 dash plus 4x1 plus 8x2, okay, and now you see that we get a equation x1 double dash and x2 value just replacement in here, x2 is equal to this, okay, x2, so 5x1 dash minus 5x1 dash, okay, so x2 value you get in here, from here you can get x2 value, so equals to 5x1 dash plus 4x1 and 2 into 4x2, okay, 4x2 value is you see x1 dash 2x1 dash minus 5x1, okay, so we get the value is 5x1 and plus 7x1 dash and 10 4 plus, okay, minus 6x1, okay, minus 6x1. So 1 double dash minus 7x1 dash. So friends, this is the very simple that you get that m square minus 7m plus 6 is equal to 0, and similarly you get auxiliary equation m minus 6 and 1 equals to 0. So your auxiliary equation is x1 is equal to c1 1 e to the power 60 e to the power 60 and c2 e to, similarly you can get x2 is equal to c1 dash e to the power 60 plus c2 e to the power t. Okay, how you can get, friends? Very simple, just substitute. Okay, if you one process that x2 is total, convert the total equation into x2 double dash. Okay, so you can easily solve this problem. Okay, let x1 dash is equal to 5x1 plus 4x2 x2 plus 2x2 dash. Okay, and x2 dash x1 is equal to, can be written 5x2 dash minus 4x2 x1 value, just I am changing the x1 value in terms of x2 you have to write. So 5x2 dash minus 10x2 x2 plus 4x2 x2 plus 2x2 dash. So x2 double dash is equal to x2 double dash minus 7x2 6x2 is equal to 0. So x2 is equal to c1 dash e to the power 60 plus c2 dash e to the power minus e to the power t. Okay, so friends, now we go to discuss the problem. So I get these two value. Okay, c2 dash. Now again, according to the questions, t tends to 0, t tends to 0, then we get x1 0 and x2 0 equals to c1 plus c2 c1 dash, that is alpha and beta. Okay, it is alpha and beta, so xt equals to, that value is xt equals to, and xt equals to e to the power 60 plus alpha minus c1 e to the power t and c1 plus beta minus c1 dash e to the power t. Okay, so it is clear x0 does not equals to 0, so it is totally wrong. How x2 is bounded solution? Not bounded, because you see that when t tends to infinity, total values is going on infinity. So how it is bounded? It is not possible in bounded. E to the power 60. So friends, you see that e to the power minus 60, whatever I get the value is x1 and x2. x1 equals to and x2 equals to x1 is equal to c1 e to the power, okay, in here I just copy right in here, e to the power 60, okay, e to the power 60 and plus alpha minus c1 e to the power minus e to the power t and c1 dash e to the power 60 plus alpha minus c2 into e to the power c2 dash is equal to e to the power e to the power e to the power t. So multiply with e to the power minus t, then it should be 5t e to the power 5t, and e to the power minus t is multiply, so e to the power, and this is the 1. So how we say that if t tends to infinity, we can't say. How? Because it is e to the power minus e to the power 5t and this will be a constant term, okay. So if t tends to infinity, okay, t tends to infinity, e to the power minus t, okay, for all x0 does not equals to 0, x0 does not equals to 0. So how can we say that this value, because t tends to infinity for all x0 does not equals to 0, this is not possible, okay, because you can check that this value is not clear for us, okay, this value is not for clear because alpha is equal to, suppose alpha is equal to c1, okay, alpha is equal this in this case it, suppose c1 is equal to 0, maybe c1 equals to 0, it is not c1 equals to 0, there is not, okay, so equal to 0, so we get it is 0, it is 0 for all value x, it is say, so value is alpha when t tends to infinity, so we can't say that it is 0 tends to infinity, you cannot say it is tends to infinity. But when it is multiplied with e to the power minus 10t, when it is multiplied with e to the power minus 10t into mod of xt, so we get e to the power c1 e to the power minus 60, okay, c1 e to the power minus 60 and 60 into 10t, so it is e to the power minus 4t, 4 into t, okay, and another is beta minus c1 into e to the power minus 9t. So when you put infinity, then it is tends to 0, okay. So it is clear for you that why it is not why it is x0 does not equals to 0, x0 does not equals to 0, okay, for all x0 does not equals to t, when t tends to infinity, then it is not, you cannot say it is 0. E to the power minus 60, when it is multiplied with e to the power minus 60, you see that c1 is remaining, okay, when e to the power minus 60 mod of xt, so we get a constant term c1, okay, c1 and c1 and alpha minus c1 e to the power minus 5t. So t tends to infinity means it is 0, but c1 is remain, so c1 is not like 0, you cannot say that c1 is 0, c1 is an arbitrary constant, so option b is false. I hope it is clear for everyone. Thanks for watching.